Alright, this is chapter 18, problem number 9. The problem reads, two spherical objects are separated by a distance that is 1.8 times 10 to the negative 3 meters. The objects are initially electrically neutral and are very small compared to the distance between them. Each object acquires the same negative charge due to the addition of electrons. As a result, each object acquires an electrostatic force that has a magnitude of 4.55 times 10 to the negative 21 newtons. How many electrons did it take to produce the charge on one of the objects? Alright, so in this problem we're going to be using this force equation here that states that K, which is a constant and is 8.99 times 10 to the 9, equals the charges over the distance between them squared. Right, and the problem states that, well, from the problem we can pick up that we're solving for the value of one of the Q's, just because it says what is the charge. I'm sorry, the problem states how many electrons did it take to produce the charge on one of the objects. So from this equation we can manipulate it. Additionally we can assume that Q1 times Q2 is Q squared, just because the charges are the same, and in this situation, whether you take electrons from one and add them to another, we take the absolute value, so the magnitude will still be the same. So from here we get, solving for Q squared, we get Q squared equals force times the distance squared over K. Take the square root of that, so the charge on one of the particles would be the square root of force times the distance between them squared over K. So we find our our charge on one of them to be 1.28 times 10 to the negative 18 coulombs. And in order to figure out the number of electrons necessary to produce this charge, we simply divide our charge by the charge per electron, which is 1.60 times 10 to the negative 19 coulombs per electron. We do this, and for our total number of electrons, we get a total of 8.